Right now, without realizing it, you are shining. Not with metaphor or magic, but with real, measurable light. Every cell in your body is quietly glowing, releasing tiny photons into the dark. Scientists have seen it, photographed it, and what they discovered might change the way you see yourself.
You are glowing right now. This is not a metaphor, nor is it a turn of phrase meant to flatter. It is a simple scientific fact. At this very moment, your body is emitting a faint visible light, a phenomenon known as human bioluminescence. This is not the dramatic theatrical glow of a firefly, nor is it the ethereal shimmer of deep-sea creatures we imagine. Instead, it is a deeply subtle radiance, a delicate and constant signal of the life within you. The light is so incredibly weak, in fact, that it is approximately 1,000 times dimmer than the absolute faintest light our naked eyes can perceive. It is a secret our bodies have kept from our own senses. The very idea that we are perpetually shining can feel astonishing, almost like a detail borrowed from a fairy tale. We navigate our world entirely unaware of this personal aurora, never catching a glimpse of our neighbors shimmering in a darkened room or seeing a soft light emanate from our own hands. This is because the light is far, far below the threshold of human vision. But just because we cannot see it does not mean it isn't there. For decades, scientists suspected its existence, and with extraordinarily sensitive technology, they've been able to confirm and measure it, revealing a hidden dimension to our biology. This discovery invites us to reconsider the nature of our physical selves. We tend to think of our bodies in solid terms: bone, muscle, skin. So if this light is imperceptible to our own eyes, how on earth did scientists manage to measure it? The process required a combination of absolute darkness and technological marvels. Researchers in Japan led the way using a camera of almost unbelievable sensitivity. This was not your standard digital camera, but a sophisticated piece of equipment known as a charge-coupled device, or CCD camera. The CCD is cooled to extremely low temperatures, often around minus 120 degrees Celsius. That extreme cooling is crucial because it reduces the thermal noise inside the camera's electronics, ensuring the only photons detected come from the subject, not the instrument. Volunteers sat in a completely light-proof, pitch-black chamber for several hours. Every potential source of light, no matter how minuscule, was eliminated. Over 20 minutes or more, the camera gathered infinitesimally small photons trickling from the skin, slowly building an image from those tiny packets of light. The origin of this faint corporeal light lies deep within the intricate chemistry of our cells. It is not a mystical aura. It is the direct result of metabolism, converting food into usable energy. As our cells work, they generate highly reactive molecules called free radicals. You may have heard of them with antioxidants and health. They are a normal, unavoidable part of cellular respiration. Cellular respiration is how cells use oxygen to make energy. Free radicals are unstable and react with nearby molecules, lipids, fats, proteins. When free radicals interact with these molecules, they can transfer excess energy. That energy kicks molecules into an excited state. To return to normal, molecules release the extra energy. Most becomes heat, but rarely it is emitted as a tiny particle of light. It's a photon. Countless trillions of these reactions across your body produce a steady, incredibly dim glow. Imagine a vast field of fireflies. One flash is tiny, but millions create a shimmering landscape. Our internal glow follows a circadian rhythm, weakest in late morning and strongest in late afternoon, mirroring daily metabolic rhythms. Just as the presence of this light is a fundamental sign of life, its absence is a marker of its end. One of the most profound aspects of this phenomenon is what happens after death. When the heart ceases to beat and respiration stops, the intricate supply chain that fuels our cells is cut off. Oxygen no longer travels through the bloodstream, and without oxygen, metabolic processes that produce free radicals grind to a halt. The cellular engines fall silent, chemical reactions that generate photons begin to cease, and the faint light our bodies emit starts to fade into darkness. This fading is not instantaneous, but why it is a gradual dimming that mirrors the body's shutdown at the cellular level until there is only stillness and darkness. The observation of this process is a gentle, powerful illustration of what it means to be alive. Ultimately, the discovery that we glow is more than just a curious piece of scientific trivia. It is a source of quiet wonder, a fact that gently reframes our relationship with our own bodies. It underscores that we are not static objects, but dynamic systems, humming with energy that is real and measurable. This knowledge doesn't change our daily routines, but it can enrich our perception of them. It adds a layer of subtle magic to the mundane, suggesting a hidden radiance that accompanies us through every moment, whether working, sleeping, laughing, or in quiet contemplation. Because this light reflects metabolism, it may become a non-invasive diagnostic tool, mapping inflammation, cellular stress or disease, and tracking treatments, sleep rhythms, and aging. It connects us to fireflies, glowing fungi, and deep-sea fish. A grand tradition of life-creating light. As you look at your hand, see not just skin and bone, but a source of unimaginably faint light. Trillions of cells working in concert.